Hi everybody, welcome back to ARC 172 LAID drawing demos. So we have done the transferring of your figure ground data to the cubes. We have done the projection of that data up and over and the additive and subtractive versions of those. And at this point, we are now going to look at how the data can interact from the bottom and the back. As I mentioned on the call, there are different ways that this data can interact. So basically the Boolean operations of union, subtraction, or intersection. And instead of doing like a wholesale, everything on the back subtracts from everything on the bottom, something like that, which probably isn't going to result in a very interesting, an interesting final proposal. What I usually recommend is kind of taking data kind of piece by piece and looking at how they interact together. So usually I would say start with the data that's towards the front corner at the bottom, which would be, in this case, it would be this kind of very complex shape here. And I will do that, but I want to start off with some simple volumes. And the reason to do it basically from the front corner and also start with the topmost and foremost data at the back is because if you start to construct those and propose things, they might hide things that are behind once you start proposing volume. So it doesn't make much sense to come up with something really complex and interesting in this back corner if then you propose something that is in this front top side that's going to block that. But in order to just give you maybe an easier demonstration, I'll start with a couple of simple shapes. So I'll start with, even though this might get blocked by this eventually, I'll start with this rectangle here, and you can see because of this point here, it should interact just slightly with this guy up at the top here, this shape up at the top. So let's just start with those two, and then we can build. The nice thing about trace is we can add to the complexity of that just by adding other volumes. So this is basically the same process that we did when we were doing our additive and subtractive version. So I'm going to pull these pieces of data up and over the top. Oops, I should be using my non-photo or my non-print purple for this. So this is going to come up and over. And again, we're going to do this data as wireframe so that we can see how they can potentially interact. So with those coming up and over, now I can draw the points that are along those lines. So those 2 points get pulled up to this line, and these 2 points will get pulled up to that line. And then let's see how that interacts with this piece of data here. So this is already on the corner here, or those 2 volumes are on the corner. So let's go ahead and pull those points across. Again, this is already the top corner, but I'm going to redraw that just to reiterate. And that will all come across here at the front and come across here. And then that will allow me to bring these 2 points out. this data here. So how do I know where these things interact? Essentially, you can't trust anything that's not on a face. So we can look at these faces, right? Because this line is already on the edge there. So that comes across there. This is at the edge. And these projection lines, it's not the line of the data, which actually occurs right here, but these projection lines are on the face. So I can trust this point and this point, and I guess these 2 points, right? But those are not interactions, right? Because this data, these represent the projection of the data onto the face. So I would have to basically bring those back to here, right? And then I can see, okay, yes, that does interact with that. It would only interact from there to there because the data from the bottom stops occurring when it hits that horizontal line there. So this can come back and do here from there to there. So that I can trust that that would be where that interacts on that plane. And hopefully you can also see, so basically that means that this piece is just clipping a little bit into this. The other way we can double check that, because it's not just this face that works on, it's all faces. So we know that this line is on the top and this line that we pulled over is on the top. So we can trust that this interaction here, that little sliver, is also something that we know is true. So there to there and there to there. And here to here. Okay. So that little wafer thin piece here represents the interaction of this shape at the bottom and that, or essentially where that data overlaps within the space of the cube. So what does that mean? That means that essentially if we want to interpret that in the different Boolean operations, the first Boolean operation is a union. So using that data, and I'll just freehand this, but you'll want to hardline it eventually when you come up with your, but you feel free to kind of sketch it out if you'd like. But basically this is going to, in a union, that will get absorbed into the overall data sets. Right, so we'll see that line coming down. We'll see this coming down from here. And so a union would look like that. Okay. Then if we were to subtract the back data from the bottom data, let's call the bottom A and the back B. So if we subtract A minus B, then we're going to see this tower piece coming from the bottom, and a little clip out of it like so. That interaction, we'll see the bottom of that because it becomes a subtraction in this, and it comes down to the base there. Sorry, I went a little off vertical there for a second. That's A minus B. B minus A basically would be the back data minus the bottom data. So here that interaction becomes a little sliver cut out of that. So you're not going to see much of it from this front hidden line view, but you would see this, like so. So that is subtraction B back minus bottom A. And then the last of the Booleans would be just where the data overlaps, which we call the intersection. So those are the basic Boolean operations based on this data and the bottom data. I mentioned a little bit in class that there are variations on this, right? So the Boolean, basic Booleans are just the beginning, and you can kind of riff on those at your leisure and come up with some kind of interesting variations. So one thing that we've done before in class is, if you imagine, or that I've done with previous classes, you can imagine that basically kind of a variation on the subtraction. You could imagine that this data is coming out and the data on the bottom exists just as a rectangle, an invisible kind of force field that this can't come past. So in that case, you might have the top data come out, and basically the entire progression of that portion which is blocked by that, let's call it a force field, or kind of a rock in the stream, and doesn't come past, right? So that could look like this. So this is, let's see, we were talking A is the force field, so A data equals force field. And we could do that for, well, I guess because it's already on the top, this one is already kind of like a force field where that kind of stops the progress of that from going up to the top. What's another one? Another one could be that you say, well, I'm going to imagine that both of these, this comes from the bottom, this comes from the back, maybe they kind of annihilate each other, right? So as they come out, once they touch, they stop. So you could come and say, well, this top data from the back, it basically stops at that back face and doesn't exist past that. And same with the one on the bottom. You could basically say, okay, they don't extrude past where they touch. Right? So that would be like the mutual destruction, mutual annihilation. We're going to go with some Soviet era terminology. Annihilation, I think I got that right. Something like that. You could also kind of do the inverse and say, well, these things don't actually show up. Again, this is all kind of with a conceptual idea that this is coming out from the back and this is coming up from the bottom. You don't necessarily need to do it that way. You might think of it as like, okay, it's coming from this way, but in another idea, you could do something that says, well, these things are going to only come into existence when they overlap. So it might mean that, as this data comes up, it doesn't actually get activated until it touches the bottom of this shape. So, and same with this, right? So in that case, you get kind of a variation of the union, where basically you have a union of these things, and it ends up looking like that, right? So that's the idea that the data exists like this, and the data here exists just as data, and then basically when they come up and they touch, then they become physically manifested. So I don't know, let's call that one true love. Right, so those are kind of variations of the Booleans. Again, you could, if you have repetitive elements, you can think of them as switches, right? If you have a bunch of horizontal bars and you have some type of shape coming out from that, those can basically get activated or turned on and then turned off. So the basic Booleans of union, subtraction, and intersection are just the starting point for some potential other creative ideas here. So again, I would not recommend starting with stuff that's kind of further back in the cube. You can start with the simpler geometries. and kind of go from there. But really what we want to look at is what happens when the data that's kind of towards the front at the bottom, towards this front corner, and the data that's kind of along the top front here, how those start to interact, because that's what you're going to see first in the cube. It might be, it might not be that this is solid. It could come out as a subtractor. As you can see, they can be additive or subtractive. But the interactions that take place kind of at the front corner are the ones that you want to deal with first. So what I'm going to do is I'm going to pause and do kind of a high-speed version of constructing or projecting this data to the top, and I'll bring this back into the mix for that, and we'll look at kind of a more complex interaction. All right. So that was a little speeded up video of basically taking this shape on the bottom. I actually ended up, so that I wouldn't be here all night and my family could eat dinner at some point, I actually just took a portion of this larger shape and just constructed that. And that basically, so that shape comes up and shows up here on the top. And then this shape comes out from the back. So feel free, I'm going to actually, for the, to figure out how the intersections look, I'm going to use a different color with the hope that it'll show up on the video. If it helps you guys to use like a different color lead for this stuff, again, the colored leads are a little bit softer and more crayon-like than the graphite, but it might be worth it to be able to see this. But basically I pulled this kind of flat shoebox rectangle out here, and so now I'll go through and figure out where they overlap. So again, you can only trust what's on the face. So this front corner doesn't come out to the face, but we do have, because these pieces touch the face, we do have some data that we can trust. So for example, we have these points that are both on the face, and we have these points. Those we can trust. So I always, again, because I'm a little bit slow, I always like to just kind of go to the places that I know are interacting and complete those spaces first. So we know that those are part of this interaction. It's going to be a little more complex than the other ones. So from there to there, and from here to here, that's part of the interaction of the data. Right, and so then you just follow the data through, right? So this data keeps going, but this data turns and goes back in at that point. So, and what I would do is I would, again, just complete faces. So I know that this goes to here. This goes all the way back to here. So I would grab that, and again, we're drawing wireframe still. So this one is going to come back to this line, and it's going to go back that corresponds with this inside corner here, right? And then basically it will turn this way, right? Because that face, so the data itself doesn't change shape, right? So if this is an interaction of this shoebox thing with this other shape, then it's just going to follow the contours within the confines of this thing. So that comes across here. Luckily that matches up. That's always nice when the data actually corresponds. So that's basically the front faces kind of pulled in across, just like this pulls in. And then I'll go ahead and keep going around the front because that's probably easier for you to see before I pull it all around the back face. So this is probably easier to see because that data, right, this is on the face. So the fact that those come and they touch where those lines intersect, that's a good sign. That's something we like. And then this is going to come up. This is another one of those complete faces that we can see. And don't keep going with that because we know that this turns. So this comes across like so. And so does this. And we're drawing the face that would normally be hidden if this becomes a solid. And then this is the tricky part, right? Because this data keeps going, but at some point we're going to hit the end of this data. So we have to watch kind of both sets of data as we come across. So that's going to come to there and stop at that line because that is where that data stops. Okay. But then along the back side of this, so that roughly corresponds to, it doesn't roughly correspond, it corresponds to that here, right? So again, the top is a place that we can trust. So you can always project that up to the top and you can kind of predict where that's going to come across. So this is going to be interesting because as that pulls across there, it's going to hit, I think it's going to basically hit that line and then take a tiny little jog in. So we have to be a little bit careful there. So this corresponds with that line. And then it's going to probably hit there. One way I could check this is I could take this line that comes down to here. I can double check kind of where we think that's going to come in. And it looks like it actually comes in just inside of that little notch. So I don't think I'm going to pick up that notch. I think it's going to come all the way over to this vertical line, which corresponds with that corner. And then it's going to come over from there. Until it hits this line, right, which is the corner of this. And here I'm kind of completing the top face, but I can come back and get the other pieces in there. Good, and then so that completes the top face, and then I would come back and I would draw this line down till it hits there. That's going to just follow what it's doing on the top. That's going to come across to here, come up, going to come out. And if we did that right, that should come in just right there. Okay. Pretty close. So, it might look like a jumble of craziness right now, but these are all the lines I need to figure out the Booleans here. So I will again go through the Boolean operations for this. So try not to get confused. I know it is kind of confusing, but go with what you know. So Let's do the union first, and I'll try to do it so that you get them all on one sheet. Okay, so union. We know that this thing, topmost data, is going to stay present. So we can go ahead and draw that first. Okay. And then this is going to stay present down to here, but then that face, because we're doing union, is going to disappear into that piece, right? Because that is the corner of this thing coming out. Yeah. And that's going to come down, it's going to come over, that's going to come all the way down. So again, under the principle that we try to complete faces where we can, that's kind of how I like to do it. And that comes up, get this kind of cross shape. This comes over, disappears into that shape there, right? The rest of this piece goes across, or gets absorbed into the overall union. And then this is going to show up again as the union piece kind of coming across. Going to come down and out. This is the intersection, or the place where the data overlaps. So that's going to again become all flush here. So you're going to get this thing is going to look like so. This is going to come down to there. That's all absorbed in. And then let's see the top of the shoebox. And let's see, did I miss anything? No, I think that's it. So that's the union of those two. And I know it's a lot to deal with, and a lot of it, hopefully you guys will be able to see it, but I wanted to show you a more complex one as we move forward. All right, subtraction of the, let's see, we call it the bottom A. So let's do A minus B. A minus B. So it's going to be the bottom data minus the back data. So again, if we're just removing the bottom data, we're still going to see this thing at the top. Right? And then this is still going to come down, but then when that thing comes in, then we know that thing, instead of being absorbed in, that's going to go away altogether. So then we know that this will pick itself back up here. And like I said, I like to just go with where I know the planes, or I can see the planes, because it's easier for me to see that way. So then this is going to come across to here, right, because that's my subtraction. This then is going to basically come across, because that is outside of the realm of this data. So we're still going to have that. Let's go ahead and see if we can complete this piece. Oh, see, I should have gone top down, because this is going to come across here. This is going to come out. Yeah, so sorry about that. I'll come back and remove that, erase erase that portion. There's a good demonstration of why we go from the top down. And this is going to come across and be like so. You see that line going out or in through there. Let me I was almost going to erase without an erasing shield, but I know you would run me out of town on a rail for that. I would do it to myself. So let's get rid of that portion. That should be hidden in this. First, I tell you not to set up a drawing station on your dining room table, and then I do exactly what I tell you not to do. Okay. So that is basically this vertical data with the horizontal data subtracted. So let's try B minus A, the back minus the bottom. Okay, so let's go top to bottom. So we know that that stays because that is removed, or because this data goes past where this data exists. That is going to get taken away. Okay, but I'm not going to get tempted to go down further. So then we know that that whole piece has been removed, but we still have a little piece here. We still have this portion that's out in front. And we still have this space in between where that notch is. But I believe this whole piece, yes, that whole piece is gone. So it's working with the same lines that we drew, it's just some of them show up and some of them don't. So we did it the right way that time, and I didn't draw the parts in front that are going to get hidden. But that is basically subtracting the bottom data from the back data. It looks like that. And then the intersection is maybe easier to see because then we're basically just drawing a hidden line version of this interaction that we constructed. Yeah, intersection. Okay, so two simple shapes, and then one simple shape and a more complex shape. That's basically the process of looking at individual interactions. So the next step would be, okay, well, what happens when I add in this piece to that interaction, right? Does that, because this thing is similar to this, are they both going to subtract? Or you say, set up a rule that says, well, basically the rectangles that are wider than they are tall or kind of greater than a 2-to-1 proportion are going to do a certain thing, and then this is going to do another thing. So it's not going to just be like a pair of interactions. You're going to have to factor in multiple interactions with those shapes and figure out how the interactions work together, right? So subtraction typically removes one of the pieces of data, but maybe you have the data still exists and it does something else or it creates a force field. So this is kind of like design. So that's it for this demo. I'll be doing more of these. This is basically what you're going to be working on for the next couple weeks. So don't freak out if you don't quite get it right away. It's just something you have to keep doing over and over again, and you'll get better. So I will post onto our shared folder. I'll post images of these constructions so you can take a look at them in more detail and see if you can figure them out. Okay, thank you.